Hey, what's up, Alexis? How you doing?
Good, how are you?
Good. How's Felix doing?
Just barking about in the backyard.
Oh, right on. What kind of dog is Felix?
Felix is a boxer lab mix.
Boxer Lab mix. Is that your favorite dog? Boxer or lab or what's your favorite dog?
Um, I think I have way too many favorite dogs, but he's sweet. So,
You know what a computer scientist's favorite dog is?
what?
A pointer. Yeah, I told you I'm gonna bring in the cheese.
Nice segue.
uh, what do you know what a pointer is?
Absolutely not.
A pointer is basically an integer.
An integer?
Yeah, it's just an integer.
What does that mean?
Well, I'm glad you asked. A pointer is basically another data type that basically holds an integer, but it holds a very, very specific type of integer. And that integer is actually a memory address, right? So a pointer is basically a variable that holds memory addresses. So why do you think we would want to create a variable that can hold memory addresses?
No clue. Can you tell me?
Absolutely. I'm glad you asked. So, so let's talk about local variables for a second. All right, let's go back to our old self, and let's talk about local variables. So suppose I was inside of a function int main, right, and I was to create a variable int x, and then somewhere down the line I'm doing whatever. What happens when I reach this particular the end of the scope? What happens to x when I do that?
It gets deleted.
X, yeah, x actually gets deleted, which means that if I wanted to create a function here, I actually can't go and try to change the value of x here, right? Because, well, one is out of scope, and then also by the time we get here, it gets deleted, so it doesn't exist anymore. But what if I didn't want to? What if I wanted to actually use x outside of the scope?
Then I'm assuming you would use a pointer.
Yeah, you are absolutely correct. That is a great assumption. Great assumption. So let's just kind of talk about how what a pointer is and what exactly is it doing. So a pointer is basically a variable, right? And it's getting created just like any other variable. It's getting created in a static memory. So let's just write some static memory. And that is probably the best box you've ever seen in your life. You're welcome. Um, let's go ahead and think about our static memory. And so here I'm just going to go ahead and write a little chart. This is our name. This is the value of our variable. And then this is the address of our variable, right? And so like we've seen before, right? If I was to be an int main and I was to create a variable int x, and let's say we set it equal to 5, then in our static memory, we're going to have x. The value is going to be 5. And then let's just say that it is at address 1000, right? And that's inside of our static memory. And we call this our static memory because the compiler knows how to handle this, right? The compiler knows when this variable goes out of scope, then it will delete it out of the memory and free up the static memory for another variable to take to take that memory address.
What do you mean by it goes out of scope?
That means that when we go out of the block of code, right? So remember, between curly braces means block of code, right? So that means that the life of this variable, since this variable was created inside of this block of code, then it only lives in that block of code. And as soon as we are no longer in the block of code, the life of that variable is over and that variable gets deleted out of your program.
Okay.
Does that make sense?
Yes.
Great, thank you. So when I create a variable X, right, it gets put in my static memory and it's gonna stay there for its entire lifespan. Now, if I wanted to create a pointer, the pointer is gonna do the exact same thing, right? And so just a little sneak peek on how to create a pointer. We create a pointer, something like that, right? And so that's gonna go ahead and create a variable inside of the static memory. It's gonna give it a memory address. Let's just say that it's 1001. And there's garbage in the memory right now. So right now, the value of that pointer is just garbage. Now, if I ever wanted to use use a pointer so that it points at something, right? Then all I have to do is assign the address of that variable to the pointer. Because remember, a pointer is nothing but an integer that holds an address. And the address that it's holding is the variable that it's pointing to.
Do you want to re-explain that?
Absolutely. If we pointer is designed to point at a variable, right? To be able to retain the address of where a variable exists inside of our memory. That is the sole purpose of a pointer.
Okay.
So in
So
order
is it kind of like a way to mark where your value is in memory?
exactly, it's to be able to figure out where the value is and keep that value, right? Because if we look at this static memory, right now we look at X, right? The name of the variable is X. Its value is 5, right? That means that X is representing the number 5. And then it just has a memory address that the compiler assigned to it, right? The compiler just gave it the next available memory address inside of the memory.
Yes.
Well, our pointer is going to do the exact same thing. It's going to, when we create a pointer, it's going to create a variable for the pointer, and then it's going to it's going to find a place in the memory, right, to place that pointer. And then you're able to give that pointer value, right? As right now we haven't given our pointer value, right? So that's why there's just garbage inside of as the value for our pointer now. It's just,
Okay.
but as soon as we set the value of this pointer, then the value of this pointer will change in memory.
Okay.
Now, the value of this pointer is always going to be a memory address. And it is basically the memory address to whatever it is pointing to, whichever variable it's pointing to.
So then there is a difference between the actual pointer's memory address versus what the pointer is actually pointing to?
Absolutely. That's a great question. Yes. The memory address of the pointer is basically where the pointer was created inside of the static memory. The value of the pointer will be whatever variable the pointer is pointing to.
Okay, that makes
And by
sense.
saying pointing to, that means what variable is it trying to remember address, right? I want to just think of a pointer as having like a little pocketbook, and the pocketbook could only fit one address in it, and that's going to be the address of another variable. It's going to just remember where in memory that variable exists.
Okay.
All right. So how do we assign the memory address to P? Because if I was to do you think that I could just say P is equal to X?
No.
And why can't I say P is equal to X?
Because X is a value currently rather than a memory address.
Yes, absolutely. That's correct. If we were to look at a pointer differently, let's say that, I'm sorry, if we were to look at other variables, let me just get pointers out of the equation for a second. If I were to create a variable int y, and I set that equal to x, that is actually changing the value of y to x, right? It's not going to give me the address of x. It's just going to say, all right, whatever value is in the memory for x, we're going to just go ahead and put that value in the memory where y exists, right? So the same thing would apply if I were to say p equals x. And actually what will happen if I say p equal x is that we're going to get a error, right? Our compiler is going to note that our pointer is not able to point and store an integer. It only knows how to store an address. Even though at the beginning of the video, I said that a pointer is nothing but an integer, which is true, right? An address is nothing but an integer, but the compiler has made a distinction between the two. And so a pointer can only store the address and not an actual integer value.
That makes complete sense.
All right, great. So so now let's talk about how we declare and how we actually use pointers, right? So to declare a pointer, so if C++ isn't confusing enough for you, it's going to get a little bit more confusing now. So what is this? What do we use asterisk for in C++ so far? What have you learned so far what an asterisk is?
Like multiplication.
Right, multiplication, right? Well, we're going to find now that asterisk has two more meanings, right? One of the meanings means that a variable is a pointer. And the other asterisk is going to mean that we are dereferencing.
Dereferencing?
Yeah.
What does that mean?
What does that mean? We're going to find out. Just hold on to your seats and enjoy the ride. All right. So let's talk about this first one first, and then we will definitely get to what dereferencing is. All right. So to declare a pointer. All right. So when we're declaring a pointer, we need to have our data type. Right. And then we also need the asterisk, right? But we need the variable is a pointer asterisk. And I probably should have put this under. I'm going to put this under. Right, that asterisk means variable is a pointer. And then we need identifier. And then our semicolon, right? So that's what we need in order to declare a pointer.
Would you like to give me an example?
Of course, I would love to give you an example. Let's look at an integer pointer. So I'm going to write int, right? This is my data type. And then I'm going to follow that with an asterisk, right? This means that the variable is a pointer. And then we're going to do an identifier, right? I'm going to just say PTR. That's the name of our pointer. Right? So that is how we would declare a pointer. And so now this may look like it's an integer, but it's not an integer. This is a variable that knows how to hold the address of an integer. And so if you're ever confused about what a pointer can point to, I like to think of this, right? This is my data type, right? And then this is indicating that it's a pointer, right? So that means that this variable knows how to point to this data type. And later on, you're going to find, right, that you can do something like this. That's called a double pointer, right? So with that same understanding, if this asterisk makes the variable a pointer, and then everything else is the data type, what would be the data type that this pointer could point to?
Integer pointers.
Absolutely. It can point to this, right? This would be my data type, and then this is going to be my variable name. So that means that this pointer can now point to integer pointers rather than pointing to integers. But let's not focus on double pointers for now. Let's focus on single pointers.
Sounds good. I do have a question though.
Oh, please ask.
When you're declaring multiple pointers, or I guess identifiers within the same line, do you have to just do the integer star pointer and then keep continuing with the names? Or is there a special formatting?
That is a very great question. And that's a question that I am going to bullshit the answer. I believe that we say integer, pointer, X, and then we will say pointer Y, and then pointer Z. I've never done that before, but I'm pretty sure that that's the way we do it because the asterisk is just basically saying that this variable is a pointer.
Okay.
And you should try it. Try this at home and let me know if I was absolutely incorrect on that.
Will do.
Great.
Always.
And I'm not gonna edit that out either. All right. All right. So that's a great question. Thank you. I will. I'm gonna research that and get back to you on that. But I'm pretty sure what I just showed you is the correct way to do it. All right. So now let's go ahead and start setting values. Right. We figured out we know how to declare a variable, but I already said that I can't say int pointer PTR and then say int x equals 5 and then say PTR is equal to x. I can't do that, right? I'm going to get a red squiggly line. And why am I getting that red squiggly line?
Because the pointer needs to point to a memory address rather than an integer value.
That's correct. I'm just going to write that down. If anyone can read it. All right. So that is absolutely correct. We can't do that. So how do you think I am able to point my pointer to the address of X?
I don't know, Dave.
So let's go back to our previous computer science self. Let's look back to our previous computer science class. You remember this thing called, let's see, it was called something like pass by reference. Do you remember that term? Does that ring a bell to you?
Perhaps.
Perhaps. Tell me what you remember about pass by reference.
I believe it's when you can have a variable that not necessarily holds a value, but it references the value of a variable, and that value within that variable can be changed if you need be.
Absolutely. I think what you're trying to say is that if we were to pass our variable into a function, right? So let's say that I have a void function, and this is just going to be some pseudocode, right? It takes a parameter, and then somewhere inside here, my parameter gets changed. Then the variable that gets passed to it also gets changed, right? Whereas when it was a pass by value, that didn't happen, right? We would just pass the value and a new variable would get created and the new variable would get changed, but the old variable, meaning the variable that was passed to it, doesn't
remain the same. Yeah.
Remain the same. Right. So what did we do to be able to make a parameter work in this pass by reference manner? What did we use?
An
Right?
ampersand.
An ampersand, that's correct, right? So let's say we have a void and we probably familiar with the swap function, right? We used int a, ampersand a, and int ampersand b, right? And then we did our swap algorithm inside of here. And after we ran this function, the values of a and b that was passed to the function ends up having their values swapped, right? We all should be familiar with that process. So what like you said before, the ampersand is actually what made that possible. And why did that make that possible?
No clue, Dave.
The reason why I made that possible is because the ampersand says, hey, don't create a new variable to represent this integer a parameter. Just go to the memory address of the variable that's getting passed to it and make the changes at that memory address.
So is that signature the same as a pointer?
Is that signature the same as a pointer? What I'm trying to get at is that if the ampersand is telling us to get the address of the variable, maybe this ampersand can help us here when we're trying to actually set the value of the address of x and not the value of x. What do you think?
Perhaps. Maybe we could do pointer equals ampersand x.
Yes, you're absolutely correct. If we say, let's go ahead and change that. If we say pointer is equal to ampersand x, and believe it or not, that is an ampersand, um, then we actually now are not trying to change pointer's value to 5, but we are actually trying to change it to the memory address that was assigned to x by the compiler.
That looks good to
So,
me.
so what does that mean? If I have a pointer that's pointing to the memory address, so what? What does that mean?
Maybe we can access the value at that memory address.
You are absolutely correct. Yes, we can use our pointer to point to access the address that it's pointing to.
Is that where dereferencing comes in?
You got it right on the nose. So let's go ahead and talk about that. So how do you think we might use the dereference operator to actually access the value located at the memory address that's stored in our pointer?
Maybe that multiplication sign slash asterisk could go in front of our pointer identifier.
All right, so you say we do asterisk pointer.
And then you can set that equal to a value.
So do I need to make it equal to an ampersand?
No,
And why not ampersand x?
because that's the memory address of the variable x.
Absolutely, that's the memory address. And when we are dereferencing, we are actually no longer talking about the memory address, but we are talking about the value of that at that memory address. So let me just kind of draw that out because that probably makes no sense right now, but let's kind of draw that out. So let's look at our memory, right? And so far we had, right, if this is going to be our name, value, and address, we had our x, right? And we set the value equal to 5, and we're just going to say that it was at index 1000. Then we created our pointer, right? And if we look above, right, we said that our pointer is now equal to the address of x, right? So what does that mean the value here would be? Oh, that's not what I meant. What would be the value that goes here?
I believe it would be 1000.
It would be 1,000. That's correct, because we said, right? Let me just kind of draw there. We're saying that pointer is equal to the address of X. That means that the value of the pointer is the address of X, right? And what is the address? Well, the address of the pointer is whatever the compiler decided to put that pointer in the memory, right? So this is our pointer. It lives at 5,000, but it's pointing to X, meaning that it is going to record the address of X, and that's going to be its value. You had a question?
So then how do you get the value of X from the pointer?
So how do we get the value? Just like you said earlier, yes, we want to use the dereference operator, right? Dereference. Meaning that if we say star P, then now we are going to refer to the value at the address that the pointer is pointing to. So what the dereference operator does is
Star
it will,
P or
sorry, star pointer, thank you, star pointer. So what the dereference operator does is it will first look at, find pointer inside of the memory. It's going to look at the value of pointer, which is always going to be an address of whatever it's pointing to. It's going to then go to that address, and it's going to find the value that is stored at that address.
Seems pretty legit. So if you want to see out that value,
If I want to see out that value, so yeah, so what do you think would happen if I was to see out? So what if I said see out and I wanted to see out pointer? What do you think would output?
the actual address of the pointer in memory.
Absolutely. This is going to output the value of pointer, right? The value of pointer, which is an address.
So is that couting the actual address of the pointer, or is it couting the address of whatever it's pointing to?
That's a good question, right? So let's look at if we were to output X, for example. If I were to say C out X, what does that address, what does that output? Does it output the address of X, or does it output the value of X?
It outputs the value.
Yeah, it outputs the value, right? Outputs the value. So the same applies with a pointer, right? A pointer is nothing but a variable that holds a value. It just so happens that the value that it holds is a memory address. So right now, looking at the code, looking at our memory, what would output when I say output pointer?
1,000.
Yeah, it's going to output 1,000. So now that we know about dereferencing, what would happen if I were to output star pointer?
You would get 5.
I would get 5. And why do I get 5?
Because since you're dereferencing the pointer, you're getting the value that is at the address that the pointer is pointing to.
Absolutely, that's absolutely correct. So I'm going to go to find the value of my pointer, and I know that it's an address. Then I'm going to go to that address, and I'm going to find the value. That's what that little dereference operator does. And so you're absolutely correct. If we were to use the dereference, that means that we don't want to output the value of pointer. We want to output the value of what the pointer is pointing to. And in this case, it's pointing to X. So it's going to output the value of X. So let me ask you a question. What would happen if I were to say, I'm gonna dereference my pointer, and now I want to change the value to 10? Tell me what's gonna happen here in the memory.
X's value is going to change to 10.
X's value, but why not pointer's value, right? I said PTR is equal to 10, so why doesn't the value of PTR change? Why doesn't this value change to 10?
Because you used the dereference operator.
Absolutely, I used the dereference operator, so I said find the address that pointer is pointing to, go to that address, and then change that value to the number 10.
So
Go, go on.
what happens if we go back to the pass by reference idea and we end up outing ampersand pointer?
So if I were to go and say C out ampersand pointer, well, what does ampersand requesting? When I put an ampersand in front of a variable, what is it requesting?
The memory address.
It's requesting the memory address, right? So this is going to output the memory address of the variable. So looking at our chart, what would be the memory address of our variable pointer or PTR?
5,000.
5,000, yes. But why isn't it why is it saying, why wouldn't it be 1,000?
Because you want the actual address of the pointer, not what it's pointing at.
Absolutely, we want the address of the variable. If I put a reference operator, that means give me the address, give me the place where that variable is located in the memory, not the value of the variable, right? But the place in memory. The value of this variable is an address, but it's not the address of the variable, it's the address of another variable that it's pointing at. It's absolutely correct. So let's go back, let's rewind back a little bit to what we just did here, right? On this line here, we said dereference our pointer and change the value to 10. So what happens now if I were to C out X?
You would get the value of 10.
I would get the value of 10. But what do you mean? Because I started off with X being the value of 5. Why is X equal to 10 when I never said something like X equals 10? Isn't that the only way that I can make X turn to 10?
No.
Yeah, right. Until today, it was the only way. But now we see that there is another way, right? By using pointers, because pointers can actually go into the memory and make changes. There's some sneaky little suckers. So any questions about pointers?
No?
Well,
I think you answered everything.
let me ask you a very important question. Are boxers and labs still your favorite dog?
No. I
Oh,
think pointers might be.
yeah. All right. Well, my work is done here.